So what is Newton's first law of motion? Newton's first law is every body continues to be in its state of rest or of uniform motion along a straight line unless it is acted upon by an external unbalanced force. Okay, so let me write it. So every body continues to be in its state of rest or of uniform motion unless there is an external force. There is an external unbalanced force. External unbalanced force acting on the body. So for an example, let's suppose you strike a cricket ball. Okay, so that cricket ball is rolling on a floor. Okay, it's rolling on the floor. So what happens? After some time, it comes to rest. So after some time, it comes to rest. So the Aristotle, okay, and other Greek philosophers, they used to believe that this is the natural tendency of body to come to rest. Okay, and to keep on moving those body with uniform speed, you need what? You need an external force. Okay, and this is how we observe the world. Okay, this is how we observe, right? So we see that a ball which is moving on a floor, it eventually comes to rest. Okay, but Newton told us that it's not that the ball has natural tendency to come to rest. It's because of some other force is acting on it. Okay, so that other force is force of friction, right? Which force is that? Suppose this ball is rolling on this floor and it comes to rest. It's because of what? Force of friction. Yes, no?
Yes, sir.
Yes, sir.
Okay, so if this is a frictionless floor and then this ball is at rest on this floor, and let's suppose there is another ball. Okay, or let's suppose this ball is moving, and suppose there is another ball which is moving with a, sorry, this ball is at rest, this ball is moving with uniform speed. Okay, so its v is constant. So Newton's first law says that if object is at rest and object is moving with uniform uniform velocity, then the state of rest and state of uniform motion are identical. In what sense? That the net external unbalanced force acting on these two objects will be equal to what? It will be equal to 0. So if there is some force, then there will be some acceleration. Okay. So can you tell me what are the forces acting on these bodies? One force is gravitational force, right?
Yes, sir.
Okay, so gravitational force is acting on this body. F is equal to mg, and then if there were only the gravitational force acting on the body could go inside the earth. Okay, so what happens is that floor on which the body is resting, it also exerts a force, okay, which is opposite to the gravitational force, and it is known as what? The normal reaction. So normal reaction due to any surface, it always acts perpendicular to the surface. Okay, so that force is force of normal reaction, which acts vertically upwards. So this is force due to this is force due to the floor. And since this force, the force due to the gravity and the normal reaction, they balance each other, the net force acting on this body is 0. And that's why the body remains at rest. Okay, so that's why the body remains at rest. This body is moving with constant speed. in same direction. So we can say it is moving with constant velocity. Even its direction is not changing. Okay. So then in this case, forces acting on this body are same. Okay. So this case and this case is same. If we think about the forces. So there is a gravitational force acting on this body. F is equal to mg. And if it keeps on moving with constant speed, there is only this normal reaction due to the floor acting on this body, and sum of these two forces is 0. Okay, so normal reaction is upwards, it is positive. Gravitational force acts downwards, it's negative. If you add both of them, it will be equal to 0. So since the net force acting on the bodies is 0, therefore either the body will remain at rest or the body will keep on moving with the uniform sorry, with the uniform velocity. Newton's first law is clear?
Yes, sir.
Yes, sir.
Okay, so now what can you say if you observe a body at rest? So can you say that there are no forces acting on the body? If some body is at rest, can you say that there are no forces acting on the body?
No, sir.
What can you say? You can say that the sum of all forces acting on the body is equal to 0. If body is moving with uniform
Zero.
velocity, yeah, if body is moving with uniform velocity, in that case also, the sum of all forces acting on the body is equal to 0. Okay, if there is an unbalanced force, if net force is not equal to 0, then there will be some acceleration. Okay, so that's what the Newton's first law says. So this law was basically given by Galileo, but because Newton gave us the complete framework for mechanics and he stated it in beautiful words, all three laws. Okay, it is named after Newton only. All right, so what can we say? So if a body is at rest, a body is at rest or moving with uniform velocity, then we can say that sum of all forces acting on the body is equal to 0, and it is a vector sum because force is a vector quantity. So I can go from 1 to n. Okay, so this is clear. So let's suppose that there is a rigid support like this. Okay, and then these are two wires, okay, connected to the rigid support at some angle, and you have a mass hanging from this rigid support, sorry, from these two wires. So this is some mass. Okay, so let's suppose m is equal to something. Let's suppose it is 5 kgs or something. Okay, and now you want to find out the tension in the strings. Okay, you want to find out the tension in the string. What is tension in the string? So when you stretch a string, what happens? There are molecules within the string which try to restore the string back. Okay, so they pull on to each other, and that's why the string is under some kind of tension. So that force is known as tension in the string. Okay, so for an example, you can consider there is a rope hanging from your ceiling, and you hang holding that rope. Then what happens? So your force will act downwards, right? If the so what happens? You are pulled downwards because of gravity. Okay, and if there is no other force, if there is no upwards force acting on you, you will be pulled downwards. Okay, you will fall down. But the string, so you pull on string and string pulls on you. So that force with which string pulls on you, it is known as tension in the string. Suppose this angle, is equal to 45 degrees. Okay, so I want to find out what would be tension in these two strings. We can resolve the tension along two components, right? One vertical
Yes,
component
sir.
and one horizontal component. So you can resolve the tension. So what will be this component? So if this angle is 45 degrees, this one will also be equal to 45. Okay, so this is, I can say, it is t sine 45. This component is t cos 45,
T cos 45.
right? And for this one, this will be t sine 45. Okay, t sine 45, and this component, sorry, so component here will be t cos 45. So you can see t sine 45 and t sine 45, they get cancelled out. Okay, and component of tension in vertical direction, they get added. So it is 2 times t cos of 45, right? Net force in upward direction is 2 times t cos of 45, and net force is downwards direction is m times g. So you can say 2 times t cos of 45 degrees is equal to m times g, right? And what is cos of 45? 1 upon root 2.
1 by root 2.
So 2 times t multiplied by 1 upon root 2 is equal to m is 5,
50.
50. Okay, so this is equal to root 2t is 50. Take root 2 on other side. So t is equal to 50 divided by root 2 newtons. Okay, this is clear. This
Yes,
numerical
sir.
is clear. So now next, Newton's laws, they hold true in a particular frame of reference. So you know, what do you mean by frame of reference? So what is a frame of reference? So you need some reference to record the motion, to keep track of motion. Okay, so what are all the things that you need? You need an observer. Okay, so you need an observer plus a coordinate system plus a clock. Okay, so observer will observe the body performing motion, and coordinate system and clock will help him to keep track of motion. So at which point that body was there, okay, at a particular time. So he or she will keep track of that thing, the position and the time. Okay, this thing is known as frame of reference. So now there are two types of frame of references. One is known as the inertial frame of reference. The other one is known as non-inertial frame of reference. So what is inertial frame of reference? So the inertial frame of reference is the frame of reference in which observer is either at rest or moving with constant velocity. Okay, so there are two types of frame of references. One is the and inertial frame, and the other one is non-inertial frame. So observer is at rest or moving with constant velocity, with uniform velocity. Okay, and what is non-inertial frame? So observer is in acceleration. So observer is in acceleration. Okay, and Newton's laws, they hold true in inertial frame of reference only, and they don't hold good in non-inertial frame of reference. So here this observer can apply the Newton's laws. Okay, so Newton's laws hold true, and here Newton's laws are not valid. Okay, Why so? It's because, let's suppose, let's consider a bus. Okay, so there is a physics student who have just learned the laws of motion, and he wants to apply those laws of motion on everything, every possible thing. Okay, so bus is at rest, and suppose there is some person walking on the street. Okay, so now this student observes this person, and he says, okay, so first let's consider he is at rest. Okay, the person is at rest. So he looks at the person, then he says that there are two forces acting on the person. The person seems to be at rest. So there is gravitational force acting down, normal reaction acting up. So sum of these two forces is equal to what? It is equal to 0. And that's why the person is at rest. Okay. Then suppose the bus moves with some uniform speed, v, uniform velocity in this direction. So now for this student, this person is moving backwards with uniform velocity v. Okay, and still, so suppose he doesn't know that the bus is moving. So for him, this person is moving, okay, towards left with uniform velocity v. And now he can say that yes, person is moving backwards with uniform velocity v. So what are the forces? So sum of all forces acting on this person is equal to 0. So still he is correct, right? The velocity is relative, but the force that he is calculating, okay, he has calculated correctly that there is no acceleration. Okay, but now what happens if this bus itself is accelerating in this direction? There is some acceleration. Okay, bus is accelerating. Then what will happen? So for this student, this person will be accelerating towards left, right? And now if the student doesn't know that the bus is moving, okay, suppose it is closed bus, right, AC bus with closed glasses, everything, okay, and uh, so actually he will know that, okay, but let's suppose, then for him this person is accelerating backwards. Okay, so now what would be his reasoning? That since the person is accelerating backwards, there must be some force acting on the person in backwards direction, okay, which gives rise to this acceleration. So will he be correct? Of course not. Why is not correct? It's because he is in non-inertial frame of reference. He is accelerating. He himself is accelerating, so he cannot apply Newton's laws. Okay. What is Newton's second law? The rate of change of momentum of a body. Yeah. Tell me.
F is equal to ma.
Yeah, that is true. F is equal to ma, but it is half truth. Okay. The full law is the rate of change of momentum of a body of a body is directly proportional, is directly proportional to the external unbalanced force acting on the body, and it takes place in the direction of external unbalanced force, in the direction of external unbalanced force. Okay, so we said that the force is unbalanced, so I will just say it takes place in the direction of external force. Okay, so all right, so do you know what is momentum? Momentum is product of mass and velocity. Okay, so momentum p is equal to mass times velocity. So Newton's second law says that the rate of change of momentum, so dp by dt, is directly proportional to the external unbalanced force acting on the body. Okay. So now here this momentum is product of mass and velocity. Okay. Velocity is a vector quantity, so momentum is also a vector quantity. Right. So momentum is also a vector quantity. So dp bar by dt, the rate of change of momentum, is directly proportional to the external unbalanced force, and it takes place in the direction of external unbalanced force. Okay. So now if you remove this proportionality sign and put an equality sign, a constant will come. Okay, so you will have dp bar by dt is equal to some constant times f bar. Okay, so force acting on body, you can keep constant on this side or this side, right? So there will be a constant if you remove the proportionality sign. So now the concept of force as a mathematical equation was being introduced for the first time. So physicists are known to keep the things simple. So now since you are discovering this concept of force, so you need to form some kind of unit for it, right? So this constant will have some value. So now they chose unit in such a way that this constant is equal to 1. Okay, so they call this constant is equal to what? 1, right? So if you introduce something to the world, it should be simple, right? So force is equal to force acting on the body, it is equal to what? Rate of change of momentum of body with respect to time. This is the Newton's second law. Force is equal to dp bar by dt. So that is d by dt of what? Mass times velocity. Now we know the product rule of derivatives. So if you take derivative of this, it is d by dt of m multiplied by v plus m as it is multiplied by derivative of the second term. Okay, so if you have product of two terms, the derivative of that product is equal to what? Derivative of first term multiplied by second term as it is plus first term as it is multiplied with second term, derivative of second term. Okay, so here you can write f bar is equal to this thing. Okay, now most of the times we encounter the cases where mass is constant. Where mass is what? Mass is constant. So if mass is constant, dm by dt will be equal to what? It is equal to 0. dm by dt is equal to 0, right? So now f bar will be equal to just m into dv bar by dt, and now this dv by dt, we know it is acceleration. So f bar force is equal to mass multiplied by acceleration. Okay, so this is true only when mass is not changing. It's not true when the mass is changing. Okay, so it is half truth, right? So this is Newton's second law of motion. So what is Newton's second law? If you want to say it in one equation, then force is equal to dp bar by dt. Okay, so for constant acceleration, what can you say? Suppose the initial momentum p1 bar is equal to m into v1 bar. Okay, so initial momentum p1 bar is equal to mass multiplied by initial velocity. Final momentum at time t, p2 bar is equal to mass multiplied by v2 bar. Okay, then how can we write this? F bar is equal to change in momentum divided by change in time. So we can write this as p2 bar minus p1 bar divided by t2 minus t1. So this is momentum at time t1. Okay, at time t1. This is momentum at time t2. So we can write what? So F bar is change in momentum divided by time. So change in momentum is equal to what? You can take that t2 minus t1 on the other side. Okay, so you sorry. So you get F bar multiplied by t2 minus t1 is the change in momentum. P2 bar minus P1 bar. Okay. So force multiplied by time is equal to change in momentum. So when is this valid? When the force is constant. Okay, this is for constant force. Force multiplied by time is change in momentum. You got this? Yes, no?
Yes, sir.
Okay. Or if I want to find out average force, okay, this you can say either it is constant force or it is average force. Okay. So if you find change in momentum divided by change in time, it is your average force. Okay. So right, this is clear. So let's discuss one more thing. One more thing. So okay. So what is Newton's third law of motion? Everybody knows.
For every action, there is an equal and opposite reaction.
For every action, there is equal and opposite reaction. Right. So Newton's third law. This is Newton's third law. For every action, there is always an equal, opposite, and simultaneous reaction. Now, Newton's choice of these words, action and reaction, it might be slightly misleading. Okay, so these are beautiful words. To every action, there is always equal and opposite reaction, and that's why you can forget about Newton's first law, you can forget about Newton's second law, but Newton's third law, nobody will forget. Okay, so this doesn't mean there is equal and opposite reaction. This doesn't mean that action and reaction happen at different times. Action and reaction, they happen at the same time. Okay, so for an example, so let's consider this example. So there is a man standing on this floor. So what is action force and what is reaction force here? Can you guess? Or which is the action reaction pair? Any force can be action and anyone can be reaction. Okay, so there is weight of this man acting downwards, right? Since earth is pulling on the man, there is weight to this man which is acting downwards. So man is pushing the floor downwards with the force equal to his weight. And what is reaction? Reaction is the normal reaction. Okay, so normal reaction due to the floor. So two bodies are in contact, there will be action reaction forces acting due to each of those two bodies onto each other. Okay, when you give somebody a punch, the reaction is not that person will give you a punch back. What is reaction? When you give punch, let's suppose you hit his face. What's happening at the same time? His face is hitting your hand. Okay, so that's the action and reaction. Okay, so now let's talk about one more thing. We'll discuss about the Newton's third law uh, and law of conservation of momentum in more detail afterwards. Before that, let's talk about rocket launching. Okay, so let's suppose this is some rocket. Okay, so how is rocket launched? What happens is there is a combustion chamber inside the rocket and the fuel inside that chamber burns and the hot gases are expelled out with some rate. Okay, so some mass is sent out, right? Mass of those gases, okay, or mass of the fuel, you can say, comes out with some rate, so let's call it dm by dt. Okay, so now mass is not constant here. What is changing? Mass is changing, right? Some mass is thrown out. So dm by dt is the mass which is thrown out. So due to which, what happens here? So this part of the rocket exerts force on these gases which is in downwards direction. So these gases exert an upward force on the rocket, and due to which the rocket gets accelerated. Got this? Yes, no?
Yes.
Yes, sir.
Okay. So now let's suppose the force is equal to, okay, so force is equal to what? We know it is m times, sorry, force is equal to what? D by dt of P, that is dm by dt multiplied with V. Okay. So we have seen complete formula for the force. It is dm by dt is rate of change of momentum, right? Dm by dt multiplied with V. So rate of change of mass multiplied with constant velocity plus mass constant and change in velocity with respect to time. Okay, dv by dt. So here, now let's suppose this fuel, it is expelled out with some constant velocity. So velocity is constant, right? Velocity is constant. Okay, so dv by dt will be equal to 0. Okay, so if v is constant, dv by dt will be equal to 0. Then we can say f is equal to dm by dt, so rate of change of mass with respect to time multiplied with velocity. So this is the force due to the rocket on the gases, and same is the force due to the gases on the rocket. Okay, equal and opposite force, due to which the rocket moves upwards with some velocity. Okay, or it gets accelerated. It gets accelerated, right? So this is clear.
Yes, sir.
Yes, sir.
Okay, good. So now we can solve some problems. Okay, so let us solve some problems based upon Newton's first law, Newton's second law. Okay, so a particle moving with velocity v bar is acted by three forces shown by vector triangle PQR. The velocity of particle will, option A, change according to smallest force QR, increase, decrease, remain constant. Tell me what's the answer? Look at those three forces. Yes,
Remain constant.
remain constant because what?
Net force of the particle is 0.
Right. So net force acting on the particle is 0. Okay. So see, if you think that this is the first force, okay, so this is first vector, then this is second vector, and this is third vector. So you are ending at the same point where you started, right? So sum of these three forces, it's equal to what? 0. Okay, and therefore net force is 0. So the velocity of particle will not change. There will be no acceleration. Okay, so option D is the answer. This was simple. Okay, next one. Three forces acting on a body are shown in the figure. Okay, there are three forces. One, two, three. To have resultant force only along y direction. Okay, you want resultant force only along y direction. The magnitude of minimum additional force in the radius. Okay, so what is minimum additional force that you will need? Right. So let's find out the force in x direction. Okay, you want force in y direction. That means the net force in x direction must be equal to 0.
Yes, sir.
Okay, so let's find net force in x direction. So this angle is 30 degrees. That means this angle is 60 degrees. This angle is 30, so this is also 30, so this will be 60. Okay, so now what is force due to this force Newton? Sorry, force due to this 4 Newton. Okay, the component of force in x direction. How much is that? It is 4 multiplied by cos of 60, and it is acting towards left, so we'll take it as negative. Due to this 1 Newton, it is 1 cos of 60.
60 degree.
Okay, and due to this 2 Newton, can you see this? Due to this 2 Newton,
2 cos 60 degree.
2 cos 60 degrees. Okay, so what is the net force? It is 1 cos 60, or cos 60 you can take common. Cos 60, so net force in x direction is cos 60 multiplied with 1 plus 2 minus 4, right? Because these components are towards right, this one is towards left. Okay, so this is equal to cos 60 is 1 by 2, so it is 1 plus 2, 3 minus 4. Okay,
0.5 newtons.
0.5 newtons, right? So answer is minus 1 by 2 will be the net force acting, and you want to cancel out that, so you need additional force of 0.5 newton, right? So this was also simple.
Yes, sir.
Yes, sir.
Okay, so then let's see this next question. A stone is dropped from height h. It hits the ground with a certain momentum p. If the same stone is dropped from height 100% more than the previous height, okay, the momentum when it hits the ground will change by. Stone is dropped from some height. It hits the ground with momentum p. Okay, so p equals to its mass multiplied by velocity. So how much would be magnitude of velocity when an object is dropped from height h? It is square root of 2gh.
2 GH.
2g,
H.
right? Okay, so you know this formula.
Yes, sir.
Yes, sir.
Okay, so v is equal to square root of 2gh. So let's call this one h1. Okay, so v1 is to v2 will be equal to what? Okay, and therefore now momentum is mass times velocity, so p1 by p2 is equal to what? It is mass multiplied by velocity. Okay, so m is constant. Okay, so m will get cancelled, multiplied by velocity, which is square root of 2gh. So here g and g will get cancelled. Ratio of v1 is to v2 is h1 is to h2. So mass gets cancelled, right? So you have, so initial is suppose some height, h2 is equal to what? This 100 times, sorry, it's not 100 times, 100% more. That means it will be equal to 2 times h1. Okay, so this is h1 divided by 2 times h. Okay, so this thing gets cancelled, so 1 upon root 2. Okay, so p2 is equal to, you can say, root 2 times p1. What is root 2?
1.414.
1.41. Okay, so if p1 is 1, this is 1.414. So how many percent more? 41%, 41.4% more, right? Yes, no?
Yes, sir.
Yes, sir.
Okay, you got this, or we have to calculate that?
No, sir. Got.
Got it.
Okay, or you can do p2 by p1, Okay, P2 by P1 is 1.414. You can multiply that with 100. Okay, so you will get 141. So if P1 is 100, that means P2 is 140. Okay, so this is clear, right? Simple question. Okay, next question. So this was from JE. This is from NEET 2009. Okay, a body under action of this force acquires an acceleration of 1 meter per second square. The mass of this body must be. So this is very simple, right? So force. So first of all, find out magnitude of force. So force is equal to mass times acceleration. Find out magnitude of force. So F is equal to what? Square root of Fx square plus Fy
Sir,
square.
10 root 2.
Okay, you calculated, good. So this is equal to square root of 6 square plus minus 8 square. Okay, or 8 square plus 10 square. So how much is this? This is equal to square root of
200, sir.
200, and this is equal to 10 root 2. So they should have at least given some, okay, acceleration is equal to 1. Okay, that means force is equal to mass. So at least they should have given some value, okay, to acceleration, root 2 at least. Anyways, so very simple question, 10 root 2 is the answer. Good. Force of 6 Newton acts on the body at rest and of mass 1 kg. Okay, so you have force, you have mass. That means you have acceleration. During this time, the body attains a velocity of 30 meters per second. Okay, the time for which the force acts on the body is. So what is acceleration? It's force upon mass. Okay, 6 divided by mass is 1. So 6 meters per second squared is the acceleration. A, the body is initially at rest. So u is equal to 0. Okay, and v is equal to 30 meters per second. So this one was simplest,
Sir,
I guess.
5 seconds.
Right, 5 seconds.
Yes,
Okay,
sir. 5 seconds.
good. So A equals to V minus U divided by T. T equals to V minus U divided by A. Okay, so 30 divided by 6, right, 5 seconds. 5 seconds is the answer. Okay, so this was back in 1997. A 600 kg rocket is set for a vertical firing. If the exhaust speed is 1000 meters per second, the mass of the gas ejected per second to supply thrust needed to overcome the weight of the rocket is. Okay, so you want to overcome weight of the rocket. Okay, so what's the formula here? Force is equal to what? Dm by dt for rocket. It is dm
dm
by
by
dt
dt
multiplied with
into
v.
v.
So mass of the rocket is given. Okay, and so this is suppose the rocket. Its mass is given. M is its mass, suppose. Okay, it is 600 kgs. Let's call it capital M. Okay, this is dm by dt is for exhaust gases. Small m is for exhaust gases. Okay, so this is the mass, and what do you want to do? So the mass of the gas ejected per second to supply the thrust needed to overcome the weight. Okay, so weight acts vertically downwards. You want an upward force just to overcome the weight. That means the upthrust given by the ejected gases should be equal to what? Weight of the rocket. Okay, so upthrust is equal to what? M multiplied by G only. This is clear. How does that M
Yes,
into
sir.
G comes? Okay, so this is equal to dm by dt multiplied with V. So we have mass of the rocket, we have G, of course, it's 10, and exhaust speed v is how much? It is 1000. So let's put the values. So mass is 600, g is 10, and we want to find out dm by dt. What is v? It's 1000. So this is 6000
6
divided by,
kg second.
right. So 6 kg per second. This is the answer. Okay, this is clear?
Yes, sir.
Okay, good. Next question. Again, this was in 1994. In a rocket, fuel burns at the rate of 1 kg per second. This fuel is ejected from the rocket with a velocity of 60 kilometers per second. This exerts a force on the rocket equal to, this is direct question, right? So F is equal to dm by dt multiplied with v. So dm by dt is given 1 kg per second. Fuel burns at the rate of 1 kg per second. Okay, and this fuel is ejected with this velocity 60 kilometers per second. So what's the answer?
So 60,000 newtons.
Yeah, 60,000 Newton, because this is 1 kg per second and this is 60 kilometers per hour. So it is 60 multiplied by 10 raised to 3 meters per second. Good. So 60,000 Newton is the answer. Okay, next question. If the force on a rocket moving with velocity of 300 meters per second is 200 Newton, then the rate of combustion of the fuel is. This is also similar. Okay, so force is given. Force is dm by dt multiplied with v,
So 0.7.
0.7, right?
Yes, sir.
Let me check. Force is 210 Newton. So this is 210 Newton, and you want to find out dm by dt, right? So dm by dt multiplied with v is 300. So 210 divided by 300, 0.7. Good. So this is the answer. Okay. So a lot of questions are repeated on rocket. Okay. So where velocity is constant, mass is changing, right? So next question. Sand is being dropped on a conveyor belt at the rate of m kg per second. The force necessary to keep the belt moving with a constant velocity v meters per second will be. Okay, so here you have a conveyor belt like this. So this belt, it keeps on moving. Okay, keeps on moving like this with some speed v. So v is the speed. And now you are dropping some sand. You're dropping some sand on this conveyor belt. Okay, and you are dropping it at the rate of m kg per second. So what will happen due to this extra mass? What will happen? The belt will slow down, right? The extra mass is being deposited, so mass is changing. It will slow down. Now you don't want
Yes, sir.
it to get slowed down, so you will keep on exerting some force such that it doesn't slow down. Its speed remains constant. Okay, its velocity remains constant. So what can you say? F is equal to what? dm by dt multiplied with v. Okay, you want v constant, mass is changing. Okay, so force is equal to dm by dt multiplied with v. Okay, so same idea as that of the rocket, but applied to a different case. Okay, this is clear. So what is dm by
So
dt? dm by dt is m.
M.
M times v
So
is the answer.
MV Newton.
Right, mv Newton is the answer. Good. Okay, so a satellite in a force-free space sweeps stationary interplanetary dust. Okay, so there is no gravitational force at the rate of dm by dt equals to alpha times v, where m is the mass and v is the speed of satellite and alpha is some constant. The acceleration of satellite is, this is the question. Okay, so it is moving with constant speed v. V is the speed and m is the mass. Okay, and some dust is getting deposited, right? Dust is getting deposited. So due to that dust, what will be the acceleration? This is the question. So again, you can say F is equal to what? It is dm by dt multiplied with v, right? Because some mass is
Sir,
getting.
option D.
Option B,
D.
D. Okay, let's check. So
Yes.
force is mass times acceleration. Dm by dt is alpha times v. Okay, but now since,
Minus.
yeah, so why minus? Because acceleration will be negative because mass is getting deposited, so it will slow down. Okay, so
Okay.
alpha times v multiplied by v, alpha times v square, right? So it is a is equal to minus alpha times v square divided by m, right? So option D is the answer. Good. So this is again similar question.
Sir.
Okay. So lot of questions have been asked based upon this thing. A cricketer catches a ball of mass 150 gram in zero point 0.1 second, moving with speed of 20 meters per second. Then he experiences a force of. So this is very simple, right? He catches a ball. Okay. So final velocity of ball will be 0 in 0.1 second. So mass is given, time is given, and the ball was moving with 20 meters per second. So it's simple. So F is equal to mass multiplied by acceleration. Okay, so it is m multiplied by final velocity minus initial velocity divided by time. So it is 150 grams. So 150 multiplied with 10 raised to minus 3. V is 0 minus u is 20 divided by time is 0.1. Okay, so what is that? 20 times 150 is 3000 multiplied by 10 raised to minus 3 upon 10 raised to minus 1. So 10 raised
Sir,
to minus
30
2,
Newton.
30 newtons. 30 newtons would be the answer. Good. Okay, so this is from NEET 2001. Very simple question. Okay, a particle of mass m is moving with a uniform velocity v1. It is given an impulse such that its velocity becomes v2. The impulse is equal to. Okay, so impulse is force times force multiplied by time. Okay, we'll talk
Yes, sir.
about the impulse. But impulse is force multiplied with time if force is constant. So force is equal to what? M into v2 minus v1 divided by time. Okay, take the t on other side. So if force is constant, so you get m into v2 minus v1, or you can say this is average force. What is impulse? It is force multiplied with time. So it's this thing, m into v2 minus v1. Okay, so impulse is equal to change in momentum. So this is direct question actually.